Welcome guys to my YouTube channel. In today's class, I'm going to be solving the Jamb mock questions for 2025/2026. Now let's dive into the questions that we have for today. Take a look at question number 1. The first question here says the functional group for glucose is what? Okay, what is the functional group for glucose? First of all, it will be important for us to look at the general molecular formula for glucose. Your general molecular formula for glucose is C6H12O6. Yes, this is the general molecular formula for what? For glucose. Now, you must understand that there are 3 monosaccharides that have the same formula. Okay, these 3 monosaccharides include glucose, fructose, and galactose. They have the same molecular formula. They are referred to as monosaccharide. Okay, now, but if you have to determine the functional group for glucose, it will be important for us to look at the structure for glucose and then compare it to that of fructose. Now, look at the board. You see a structure here. This structure here is the structure for glucose. Take note of that, which is called grape sugar. While this structure here is the structure for fructose, which is known as cane sugar. Do you understand? Now, known as fruit sugar. Known as fruit sugar. Why this one is called grape sugar. Yes. Now listen to me, class. If you look the structure of this glucose, you will discover the functional group for glucose. First of all, you see that there's a functional group here, which is CHO in its condensed form. Yes, this CHO is the functional group for alkana. Yes, alkana. Alkana are also referred to as aldehyde. Yes, and the general molecular formula for this compound, this organic compound, is RCHO. So any organic compound that have the CHO is a member of the world, the alkana. So that is why we will simply say that one of the functional group in glucose is the alkana functional group. It must be noted. Now, when you look at the structure further, you see another functional group, which is the OH functional group. The OH is the functional group for the hydroxyl or the alkanol. Yes, so the two functional group here is the OH functional group and the CHO functional group. The CHO, like I said, is the alkanol. Take note of that. While the OH is the alkanol. So that is to say, the two functional group in glucose is the alkana and the alkanol. Take note of that. But when we decide to compare to fructose, we discover another functional group. If you look at this, you see that this one is a functional group on its own, the CO. The CO is a functional group for the alkanon. Yes, alkanol, the CO. Then the OH is the functional group for the alkanol. Don't forget that alkanol is also called ketone, while the alkanol is also called hydroxyl. So it should be noted that fructose has two functional groups, the alkanon and the alkanol, while glucose has two functional groups, the alkanol and the alkana. Don't forget the alkana is also called the what? Aldehyde. So what's the difference between glucose and fructose? The major difference between them is that this one is an alkana while this one is an alkanon. So we will simply say that glucose is an aldose. Glucose is an aldose, meaning it's a member of the alkana. Then we will say that fructose is a ketone. A ketone means that it's a member of the alkanon. So the difference between them is that you have the CHO here, the alkanol, and you have the CO here, the alkanon. Now let's dive into question number 2. The second question on the Jamb mock chemistry question say which of these is the possible isomers of but2-ene. Now, depending on the options that will be given to you or that was given to you. Let's quickly dive into the structural isomers for but2-ene. But what you must know is this, that isomerism is divided into two. We have the structural isomers, then we have the stereoisomers. But in an exam combination, whenever you are told to determine the possible isomers of but2-ene, they are basically referring to the structural isomers, not the stereoisomer. So let us be focused on the structural isomers for but2-ene. Isomer simply means in how many possible ways can the compound but2-ene be drawn. Let's take a look at them carefully. But means that you have 4 carbon atoms, and if I have 4 carbon atoms, that's isomers number 1. We will have 4 carbon atoms this way. Now if I have 4 carbon atoms, it is but. Then since you have the ene, it means that one of the carbon must carry the double bond. So I can decide to put the double bond here, and if I do that, this compound will be called but1-ene. Why is it called but1-ene? Because the double bond is found in the first carbon atom. So if I number it 1, 2, 3, 4, you will see that this double bond is in carbon number 1. That is why it's called but1-ene. Then you can put your hydrogen, okay? If you want to put your hydrogen, you can put hydrogen here, put here, put here, put here, put here, just like that. Do you understand? Okay. Now, what other possible ways can we still draw this particular compound? It can also be drawn like this. Don't forget, each of the compound must have 4 carbon atoms and must have a double bond. So if I put my double bond here, you number the carbon 1, 2, 3, 4. You discover that the double bond is in the second carbon. So we call it but2-ene. That's isomer number 2. Now let's look at another possible way by which this compound can be drawn. You can draw it like this. You can put 3 carbon atoms and overlap one of the carbon atoms by putting CH3 here. And then you introduce your double bond here. You have it here. You have hydrogen here. Hydrogen, hydrogen, hydrogen. It's balanced. Take a look at it. How many carbon atoms does this guy have? 1, 2, 3, 4. How many double bond? 1. Did you see now? So this compound, this one, and this one, they are isomers. But what's the name of this compound? If I number the carbon 1, 2, 3, this one now, this continuous chain, this long chain now is called prop1-ene. Yes, the word prop means 3 carbon atom. 1-ene means that the double bond is in the first carbon atom. Why this guy is called what? Methyl. But where is the methyl found? This methyl is found in carbon number 2. So the compound is best called 2-methyl. Please follow me carefully. Then prop1-ene. So in conclusion, we can say that the compound but-ene, or what they are calling but2-ene, has 3 possible isomers. Isomer number 1, isomer number 2, and isomer number 3. So any of them that you see in the option is an isomer of the compound. Is that clear? Now let's take a look at question number 3. Take a look at this beaker containing water, and the delivery tube is coming this way in such a way that the gas coming here is dissolved in the water. For you to do an experiment such as this, where the gas is directed into the water, you must know that the gas is very soluble in water. Yes, the gas is very soluble in water. Now, which gases are soluble in water in such a way that it will be directed downward into the water? The 2 gases are what? Hydrogen chloride and ammonia. Don't forget that these 2 gases are used to what? To demonstrate fountain experiments. Why are they used in fountain experiment? They are used to demonstrate fountain experiments because they are very soluble in water. So the answer to this question is option number what? A. So it is not B, it is not C, it is not what? D. Hold on for more questions. Now let's take question number 4 on the Jamb chemistry question 2025/2026. Take a look at this question, class. The compound of benzene that undergo addition reaction is what? Which compound of benzene will undergo an addition reaction? Now, do you remember that benzene is a member of the aromatic hydrocarbon? Okay, now L compound of benzene are referred to as the derivative of benzene. Now, according to this question, it said the compound of benzene that undergo addition what reaction is what? You must understand that phenol is a derivative of benzene with the structural formula of this. Take note of that. This is structural formula for phenol. Yes, this is structural formula for phenol. Phenol can only undergo substitution reaction, not addition reaction. So that is it. Benzoic acid is this way. This is structural formula for benzoic acid. Okay, so benzoic acid cannot undergo addition what reaction. Then we have styrene, which is option C. Styrene is like this. Styrene, this is structural formula for styrene. Okay, yes, this is structural formula for styrene. Styrene is also referred to as phenyl ethene. Please, it should be noted. Okay, it is called phenyl ethene. It comprises of your ethene, yes, and your what? Benzene. So take note of that. A combination of ethene and benzene is what we call phenyl ethene, also called styrene. Now, one thing you must know about this compound is that this compound is used for addition polymerization to form what we call polystyrene or polyphenyl ethene. It should be noted. So if I combine several monomers of this compound up to 20, 40, or even up to a million, you get what we know as polystyrene. Polystyrene is also called polyphenyl ethene. So please understand this, that styrene is the answer to this question because it can undergo addition reaction to form polystyrene or polyphenyl ethene. Are we together? So the answer is not xylene, neither is it toluene. So the answer to this question is what? Styrene. Take a note of that. Now, the changing of glucose to carbon by the action of concentrated H2SO4 is what? If I have, listen to me carefully, if I have glucose C6H12O6 and I add concentrated H2SO4 to it, if you add concentrated H2SO4 to this glucose, what will be the observation? Take a look. You must know that your concentrated H2SO4 is used for dehydrating carbohydrate or dehydrating glucose. What does dehydration mean? Dehydration simply means the removal of the element of water, not just water, but it removes the element of water. And the element of water is hydrogen and oxygen. So if I remove the element of water by removing this 12 carbon and 6 hydrogen, now if I remove H2O, to remove 12 carbon, you simply put 6 here so that the carbon becomes 12 and the hydrogen becomes 6. So let's put minus here. So concentrated H2SO4 removes the element of water from any compound, and then you are left with just 6 carbon atom, which is this carbon that is here. So this is known as carbon, but primarily called what? Sugar charcoal. Yes, sugar charcoal. Don't forget that sugar charcoal is the purest form of amorphous carbon. So the answer to this question is what? Carbon. So let's look at the question again. The changing of glucose to carbon by the action of concentrated H2SO4 is called what? The product here is carbon, but this entire reaction is known as dehydration. That's the answer to the question. The answer to the question is what? Dehydration, which is the removal of the element of water from a compound by the action of a what? A dehydrating agent such as concentrated H2SO4. Are we together? Now take a look at the next question. Question number 6. A compound of mass 0.4 gram occupies a volume of 500 cm3 at STP. Calculate the vapor density for the compound. How do we calculate for vapor density when the volume of the compound or the volume of the gas is given? Very easy. Take a look at this. Remember that volume of a gas at STP is equals to number of moles of the gas, number of moles times your gas molar volume. Your gas molar volume is your GMV, which is equals to what? 22.4 dm cube or 22400 cm cube in the unit of cm cube, while this is the unit of dm cube. Do you understand? So if I'm looking for the volume of a gas evolved at STP, it will be number of moles of the gas times the gas molar volume. Do you understand? Okay. Now this number of moles is the same as mass over molar mass. So that means the volume of the gas will be equals to, instead of number of moles, you have mass over molar mass times the what? Gas molar weighting volume. Do you understand? Now, this mass is given to us in the question, and the mass is 0.4 grams. Okay? Now, we are asked to calculate for the calculate the vapor density for the gas. If you want to calculate for vapor density, you must first calculate the molar mass of the gas. Why? Because vapor density is the molar mass of the gas divided by 2. So let's get the molar mass. How do you simply get the molar mass? Make M, which is capital letter M, the subject formula in this equation. So you can simply take your molar mass here and bring volume here. Okay, so molar mass will be equals to mass, you can do that, don't be scared, all over the volume times your gas molar volume. Do you understand? Now, so molar mass is equals to, what's the mass? The mass is given to us as 0.4. So you have 0.4 over the volume. They gave us the volume of the gas as what? 500. So you have 500 times the gas molar volume. What's the gas molar volume? It is given to us as 22.4 dm cube. Do you understand? Now, this is in the unit of dm cube. Now, since your volume here is in cm cube, take a look at the volume. You wouldn't use 22.4 dm cube. No, you use 22400 cm cube. Do you understand? So you are times 22400. So let's quickly divide this. 0.4 times 22400 divided by 500. That will give us 17.92. So the molar mass is equals to 17.92. So if I have 17.92, it is the molar mass of the gas. So how do you get your vapor density? Don't forget that molar mass of a gas is equals to 2 times your vapor density. So if I'm looking for vapor density is equals to molar mass over 2. So let's do the vapor density by simply saying 17.92 divided by 2. Okay, that will give us 8.96 gram per cm cube. Okay, so this is the what? Vapor density for the gas. Now let's take a look at question number 7. The nitrogen obtained from air is denser than ordinary nitrogen because of what? Now, you must understand the difference between the density of ordinary nitrogen and the nitrogen obtained from air. When nitrogen is obtained from air, it usually contains impurity. The impurity found in the nitrogen obtained from air is called rare gases, rare or noble gas. Okay, noble gases. Now don't forget that the most abundant noble gas in the air is your what? Your argon. That's the most abundant noble gas in the air. Okay, but when nitrogen is gotten from air, you have rare gases attached to it as what? Impurity. So that is why the nitrogen obtained from air is denser than ordinary nitrogen. Why? Because of the presence of what? Rare or noble gas as well. Impurity. Okay, an example of a noble gas is your what? Argon. And I said argon is known as the most abundant noble gas in the air atmosphere. Now let's take more questions. Now let us take question number what? 8. According to the reaction, ammonium chloride decomposed to give us ammonia and hydrogen chloride. What is the effect of increasing the what? Temperature. What will be the effect in the equilibrium reaction if the temperature is increased? Now let's take a look at this question carefully. You see that the reaction on the board is the decomposition of ammonium chloride. Yes, ammonium chloride decomposed to give you ammonia, NH3 gas, and hydrogen chloride gas. Okay, now these are the products. First of all, we weren't told if the reaction is endothermic or exothermic, but we do know that the reaction is what? Reversible, because it proceeds from both directions. This is the forward reaction, while this is the backward reaction. Take a look at this carefully. You have the forward reaction, then you have the backward reaction. A reversible reaction is one where the reactant can serve as the product and the product can serve as the reactant. If you look at it from year to year, this becomes the reactant, while this becomes the what? Product. But when you look at it from here to this place, this becomes the reactant, while this becomes the what? Product. So it's a type of chemical reaction where the reactant and the product are changing into each other. They are occurring at the same rate. Okay, now it means that the reaction on the board is reversible, but we have to first of all check if the reaction is endothermic, if the reaction is endothermic, or the reaction is what? Exothermic. How do we know that the reaction is endothermic, or how do we know if the reaction is exothermic? Now, one of the ways of identifying an endothermic or exothermic reaction is to look for the enthalpy change. If the enthalpy change of a system is positive, you will know that the reaction is endothermic. Take note of that. It will be endothermic. But if the enthalpy change of a reaction is negative, the reaction becomes exothermic. So it is either an endothermic or exothermic reaction. But in this particular question, it was not given, the enthalpy change was not given, so it will be difficult to identify if the reaction is endo or exo. But this is what you have to do to determine whether it is endo or exo. Now look at this reactant and look at this product. You observe that the ammonium chloride decomposes, and the only way ammonium chloride can decompose is when it is being heated. Yes, when it's being heated. That is to say, ammonium chloride, we have to absorb heat from the surrounding and decompose to give you ammonia and hydrogen chloride. Do you understand? Now, so it means that if a reactant particle absorbs heat, whatever reaction is that, it is endo. In endothermic reaction, the reactant absorbs heat to form a product. In exo, the reactant loses heat to the environment to form the what? Product. So whenever there's an absorption of heat, or in decomposition reaction, the decomposition of ammonium chloride or any other decomposition reaction by heat is called endothermic reaction. Now, if this reaction happens to be endothermic now from our analysis, it means that if I increase the temperature, don't forget, you can take your book and your pen, write it down, write it. In an endothermic reaction, increase in temperature will shift the equilibrium position to the right. Yes, in an endothermic reaction, increase in temperature will shift the equilibrium position to the right. Okay, then decrease in temperature will shift the equilibrium position to the left for an endothermic reaction. Now, if I say that the equilibrium position is shifted to the right, it means more of the product will be formed. If I say that the equilibrium position will shift to the left, it means more of the reactant will be formed. So in this question now is an endothermic reaction. They say, what will be the effect of increasing the temperature? The effect is that it will lead to the formation of the products. Yes, for endothermic. If you increase temperature, it will shift the equilibrium position to the right, but decrease in temperature will shift the equilibrium position to the left. And that's the direct opposite for exothermic reaction. Do you understand? So this question says, according to the reaction, What is the effect of increasing the what? Temperature. It will simply shift the equilibrium motion to the right, meaning more of ammonia and hydrogen chloride will be formed. Take note of that. Next question. The factor that will influence the decomposition of hydrogen peroxide the most is what? What will be the factor that will influence the decomposition of hydrogen peroxide the most? If I have hydrogen peroxide here, hydrogen peroxide, don't forget that the other word for hydrogen peroxide is called oxygenated water. Meaning, if I have water and I add oxygen, the substance automatically turns into hydrogen peroxide. So take note of that. Hydrogen peroxide is also called oxygenated water. Now, if I decompose hydrogen peroxide, it's going to give me H2O plus O2. Take note of that. If I balance the equation, I have, okay, we balance it this way so that you have 4 hydrogen and 4 oxygen. So it's balanced. This is your water, while this is your what? Oxygen. So if I decompose hydrogen peroxide, I'm going to get water and what? Oxygen. If I combine them together, like this, combine these two together, it will give me hydrogen peroxide. That's why hydrogen peroxide is called oxygenated water. You're adding oxygen to what? Water. Are we together? Now look at this question carefully. They said the factor that will influence the decomposition of hydrogen peroxide the most is what? What is the factor? Hydrogen peroxide can be decomposed under the action of strong oxidizing agent. You can use oxidizing agent, which is manganese 4 oxide. Yes, manganese 4 oxide can be the catalyst for this reaction. Okay, catalyst for the reaction. Then hydrogen peroxide can also decompose in the presence of what? Sunlight or UV rays. Yes, the hydrogen peroxide can also decompose in the presence of what? Heat. But the factor that influences the decomposition of hydrogen peroxide the most is when you add a catalyst, manganese 4 oxide, not light, not heat. Take note of that. So the factor that affects it most is a what? A catalyst. Catalyst happens to be the answer to this particular question. Are we together? Now let's take the next question. The reaction of hydrogen and chlorine will be explosive in the presence of what? Hydrogen reacts with chlorine to form hydrogen chloride. Take note of that. Those of you that wrote this exam, you can simply do your corrections now so that you don't fail it in the main Jamb exam. Now, hydrogen reacts with chlorine to give us hydrogen chloride gas. This reaction will be explosive in the presence of what? Bright sunlight. Bright sunlight. Take note of that. Or UV rays, bright UV rays. It will become explosive. It will produce heat and fire. It will become an exothermic reaction if it occurs in the presence of what? Bright sunlight. But the reactions can be controlled, this particular reaction, if it occurs in a dim light. Yes, it will no longer be explosive if the light is dim. But to be explosive if the light is what? Bright. Take a look at the next question. If the principal quantum number for an atom is 3, how many subshells will the atom contain? If the principal quantum number for an atom is 3, meaning, don't forget the principal quantum number talks about K, L, M, N. It talks about what? Shells. Yes. This one has a principal quantum of 1. This one has a principal quantum number of 2. This one has a principal quantum number of 3. This one has a principal quantum number of what? 4. Are we together? So if I have 1, 2, 3, 4, they said that if the principal quantum number of an atom is 3, if n is equals to 3, how many subshells will it contain? These K, L, M, N are called shells. But when we talk about subshells, we are talking about orbitals. Yes, we are talking about orbitals. And these orbitals are what? S, P, D, F. Yes. So how many orbitals will the atom with a principal quantum number of 3 have? Very easy. Now, the principal quantum number, write it down. The principal quantum number indicates the number of subshells. So meaning that if the principal quantum number is 3, the atom will have 3 subshells. If the principal quantum number is 4, the atom will have 4 subshells or 4 orbitals. So these numbers are the numbers of subshells. Yes, n is the number for subshells. That's one way of knowing it. So the answer is what? 3. To have 3 subshells. That's the answer. 3 subshells. Yes. So let's take more questions.